All right, yo ho ho, XV. That's my cool Santa right there. I'm gonna say it again, yo ho ho, XV. Well, you might want to clue in on this, and you might think this has nothing to do with it, but watch this. I'm gonna draw this little line here. I'm gonna put a little squiggle right here, and I'm gonna bring in some words to help make you understand this. When we're dealing with rational functions that are being graphed, where if we do yo ho ho xv, we're going to find the y-intercept first, then we're going to find the horizontal asymptote, and then we are going to factor, and that's what the squiggle line here represents, factoring it, getting it factored. I'll show you some detail. Then we're going to get the holes, which is what this video is primarily about. Then we're going to look at the x-intercept and the vertical asymptote left over in the fractional expression. So check this out. Let me pull in an example and follow you through on this. Okay, so here's an example. No, I'm going to go over to this. You're going to like this. All right, so not that part, this part. All right, so I have a rational function that's graphed here. And look over here on this side, you'll notice that it is in a unfactored form, standard form. It's a big giant fraction, and that's where we're going to get, wait a minute, yo ho. All right, so y from the yo is the y-intercept, and the y-intercept is simply coming from the constants at the end, the -3 and the -12. That was in a previous thing. I'm going to reduce that 3/12. I'm sorry, I'm not going to reduce it. I'm just going to show it just like this. And I put this on here along with a label, and I just want you to see that that is now on my graph. All right, there it is. All right, the y-intercept, and oh, my label reduced it to 1/4. So that is 3/12 reduced to 1/4. There's a y-intercept. The next thing, yo ho, all right, the h, the ho in that is going to be the horizontal asymptote, and the horizontal asymptote comes from the front end of this. Because the degrees were the same, we're going to use those leading coefficients. That was in a previous video, but there it is, and it's at y equals 1 because those degrees were the same. Now, finally, to what this video is about, well, you know what? We had to, wait a minute, let me go back. All right, let me go back to this. We did the y-intercept, and we did the horizontal asymptote, but now we need to look at the holes. And I just wanted to mention again that this squiggly line here represents that we had to factor. All right, so we had to factor the expression. Now we're ready for the holes. Okay, and let's see how the holes get handled. Let me pop back over here to this. Well, if you look back at the unfactored form, now watch the graph for a second, because I'm going to click this thing over here to put this factored form of that equation on there. Watch it, it's blue over there, you see it, and now, whoa, I'm going to take that off. All right, and the blue disappears. See the blue? See the blue gone? See the blue? And my point is that the unfactored form, the blue, when I take it off, you see that the factored form sits right on top of it. So these are equivalent, the factored form and the unfactored form. And I did that so that I could identify the whole. All right, and I want you to see that x minus 3 and the x minus 3 would cancel out. And so because those two cancel out, the whole is at +3. And +3, well, that's the x value of the whole, but you have to plug in, I'm going to put the whole on there. There it is. It's sitting at +3. And what is this? 0.57, or you'll notice it in here, 4/7. Well, that is after you probably ought to grab a picture of that. So let me pop that over here. Forgive me for a second. Now let me pop that over here next to Cool Santa. And he's looking pretty cool with the sunglasses. All right, and so now that I get to factor it, I see that x minus 3 and x minus 3 cancel out. So I'm going to take what canceled out and find the 0 of that. And what we mean when we say find the 0 of something is set it equal to 0, get the factor that canceled out, set it equal to 0, and solve it. Back to a little 7th grade algebra there, or 8th grade. And then we find out that x equals 3. Okay, so that is the x value of the whole. And to find the y value, because I need an x and a y, because a whole is a coordinate of where the graph can't go, I use the remaining component of this, the non-canceled out part, so that x plus 1 and x plus 4 that was left over, oh, bad handwriting, I'm going to take the 3 and plug it in for, well, it is the x, so it makes sense to plug it in for the x. I'm going to plug it in for the x, and I get 3 plus 1 over 3 plus 4, and that comes out to 4/7. It's like magic. And you might be saying, well, what was so magical about that? Well, take a look. So 3,4/7 to find the y. Well, look back at my graph, and there it is, 3,4/7. And where did I get the 0.57? Well, I put 4 divided by 7 in the calculator and saw what it was as a decimal to help me graph it properly. Okay, that's how you find holes. And I know we're at 5, almost 6 minutes, but look at a couple of examples. If you feel like you got it, go for it. But let me show you, let me get to the right thing. Let me show you a couple of examples on this. So here's one that it's in the unfactored form. So to find the whole, I have to factor it. So on the top, that's the difference of 2 squares. That factors into x plus 5 and x minus 5. If you didn't know that or a little rusty on it, that's okay. Maybe go back and look at factoring 2 binomials where it's the difference of 2 squares. Here, I have a GCF, a common factor of 3, so I factor that out and I get x plus 5. And now, so I have it in a factored form, I can come in here and say, okay, what cancels out? The x plus 5 cancels out. So set that equal to 0 and solve it. You would get -5. And then plug -5 into what you have left. And the only thing I have left is this x minus 5. I plug the -5 in there, and I get -5 minus 5. Makes me think that the y value should be -10, but wait a minute. See this 3 on the bottom here? So I put the 3 over there. I simplify a little bit. That's -10, not 0 on top. And I get -10 over 3, and I can convert that to a decimal to help me graph it properly. I think that's -3.333 repeating, and there's my whole. All right, take a look at this other example. This one, I just wanted you to see that I would factor the top, x plus 4, that's a horrible looking 3. And on the bottom, I would factor, and eventually I would figure out that was x plus 4 and x plus 10, and I would go through my factoring of a trinomial to figure that out, but kind of, I don't know, did it beforehand. Those cancel out, I get -4. That's my x value of the whole. I plug in the -4 down here into the x, and I get 3 over -4 plus 10 is 6, so 3 over 6. Or you might be saying, hey, Fisher, that reduces to 1/2. So at -4, 1/2, I have a whole. All right, go for it. Thanks for listening. Sorry, that was 8 minutes, but I think that was a good one for some others.